Whoops. I muted my mic since reasons. I forgot to turn it back on. Okay. So, you know, I'm happy to answer any questions. I'm not trying to say that I'm not. There's a formula on, so remember, like I specified, there's formulas on D2L. Exam prep materials. Exam 3. Here you go. This is the formula. Oh, jeez. Oh, gracious. Oh, goodness. Lord heaven to Betsy. No. Unfortunately, the quiz time has expired. So, remember, formulas are here on your formula sheet. So, they're provided for you. This is the error formula. So, but that is the time. So these are, there were, 3 questions on the quiz? These were literally the same questions. I literally copied and pasted the quizzes from the in-class assignments. Now, you might have said, I originally was going to give you just the 1 attempt, but I opened it up for 3. I don't know if my sound is working, so I've been putting important things in the chat. So I put the message in, but I suppose I could have said it out loud. I don't know if you can hear me now. Well, I hope that's not true. Let's not panic yet. There are still opportunities. There are things that exist to help. For example, dropped quiz. So, I didn't say this. I meant to say this earlier. I was thinking about my internet and got distracted. So this quiz, the quiz 3, the one that's coming up tomorrow and Wednesday. I think tomorrow Wednesday or tomorrow Wednesday Thursday. Can't remember. Look at the dates because I can't remember either. And I made the dates. It is optional if we get to the 80% mark, which last I looked, we were a ways away, but I haven't looked either in a day or 2, so we might have gotten there. But I would recommend that you take quiz 3. So you have a homework on chapter 9, but it would still be a good idea for you to do the quiz and just see how you feel, because maybe you felt good on the homework and then the quiz you realize you need more practice or whatever. So you've got those attempts on the quiz, and they can't hurt you. So you should take them even if you have the 80, if you have the drop. So yeah. Anyway, so that if you do better than you do on quiz 2, then great. You earn yourself some points. Of course, remember you have homework drops. You have a quiz drop. Hopefully, you'll still get a free in-class assignment. Quiz 3. Exam 3, final exam, 3 attempts each. Okay, I've still got a green light. I'm really nervous about you guys being able to hear me. I don't know what else to do. I reset my router, and it did not seem any better at all. But it may be working now. I don't want to jinx it. I can certainly sympathize to internet problems. I'm having my own right now. But I'm not going to open it up for you during class. Well, let's talk after class. If you have issues, I don't want you to do the quiz instead of being in class. Let's do this first. Okay. Yes. Do both. Teacher survey. Now, I don't have any information. I have no access to information about the climate study. I have no idea. So I cannot use that for incentives. The university has a list of the students that have filled it out, but they're not sharing it with the teachers. And I asked. That has come from the top. They're not going to share it with us. So I do not know. They don't know. They don't tie the survey to the student. That's completely anonymous. But they have a list of who filled it out. But again, they're not even sharing that list with the faculty. So I have no idea if you filled that out or not. Okay, so here's our outline for the chapter. So we're mostly skipping type 1 and type 2 errors for the sake of time, and of course we're skipping population proportions. We already did the hypothesis bit, and you'll get more practice in the mind tap assignment, hopefully in the quiz when you do it. There's a practice exam on D2L that you can look at, and we'll finish up with this today. So just to kind of refresh your memory, so we'll take a quick look at the hypothesis portion. So we have null, H0, and alternative, HA, hypotheses. So we have some assumption about a population parameter. My dogs are going crazy at something. Possibly a deer in the yard. They love chasing deer. Rural things. Woo. Okay, anyway, so the idea, we have these two statements, and we're trying to figure out, is the thing that we kind of, assume is true, is it true? Or is the thing that we are supposing is true, is that actually true? So the metaphor that I like to make, and I talked about this last time, is innocent until proven guilty. So I'm actually going to just turn the screen off for a second, the slide thing off for a second, because... okay. I'm going to pose the question. All right, I'm actually going to make my face big. All right, I have a question for you. So, picture a courtroom, and you're the judge or the jury. I don't care. The jury, you have a vote. Judge, you have more power. Use whichever illustration you like better. Imagine that a horrible crime has been committed, and there is a law-abiding citizen, by all intents and purposes, that's been accused of the crime, and he looks you in the eyes and he promises he didn't do it. And behind him, his 5-year-old daughter is crying, doesn't understand why everyone is saying these things and these mean things, doesn't understand why her dad's in handcuffs. He says he didn't do it, and looking at him, he seems earnest. And if you convict this man, he goes to jail. And his little baby daughter, who is just the cutest thing you've ever seen, has to grow up without her dad because her dad's in jail. How confident do you want to be to put him away? Doesn't fix what happened. Hopefully the answer is not 50-50. That as long as it's a coin toss, you'll put him away. No, innocent until proven guilty. Okay, proven. What's the burden of proof for proven? Okay, beyond a reasonable doubt. Okay, well, how much of a doubt is reasonable? 10% chance? 1% chance? 5% chance? Well, that's for each of us to decide. Personally, I'd want to be pretty sure. Certainly 80%, I don't think that's good enough for me. It's up to you. What you think is the right amount. What's it going to take for you to put a man in jail? Because they say that a lot of people go into jail that aren't criminals, but A lot of criminals come out of the jail that didn't go in. People come out criminals who weren't criminals when they went in. So you need to be really careful. And in a sense, that's what hypothesis testing is all about. We have a statement. A man is innocent until proven otherwise. And we have evidence that's being offered as potential proof, arguing against the man's innocence. Are you willing to convict the null hypothesis? Are you willing to reject the statement that this man claims that he did nothing wrong? Are you willing to say you are a liar and you're going to jail? And you're also whatever we're accusing you of. You better be really, really, really sure. So that's what this is all about. We have something that's innocent until proven guilty. And it's up to us to decide if we have enough evidence. Now, the language of statistics is that we are not given evidence directly. We're not given evidence that it's not true. We're given a lack of evidence that our hypothesis is true. So it's sort of like the way that it's given to us is not, here's the chance that he's guilty. It's given to us as, here's the chance that the man is innocent. So it's, of course, two sides of the same token. So if I say there's a 90% chance that he's guilty, there's a 10% chance that he's innocent, right? 80% chance that he's guilty, 20% chance that he's innocent. 95% guilty, 5% innocent. So the p-value that we get when we perform tests, look up on a z-table or a t-table, that p-value is the percent, p for percent, right? Percent chance, I'm emphasizing the p-value, percent chance that the man is innocent, that our null hypothesis is innocent. So at some point, the percent that he is innocent is small enough that we can say it's beyond a reasonable doubt, and so straight to jail. You know that meme? It's one of my favorite meme comments now. Straight to jail. Sorry, I needed to bring it back. I was really dark. I was really somber mood. I was hoping to bring it back up with a meme, but I don't know. Straight to jail. I think it's the guy's face that I like so much. I don't know. Makes me laugh. Not that one. Oh, geez, not that one either. Oh, which of these buttons? Okay, well, it's working. That's what matters. You can't see it. All you see is my ugly mug. All right, let's get my face out of the way. What do you say? Okay. All right, so that's the plan. Can you play me at a game, and if you win, you get extra credit? No. You can play me at a game anyway, though. I think we should have Jackbox night. That'd be fun. Yep. Everything's recorded. It's all recorded. It's all a dream. I mean, a recording. Sorry. Slip of the tongue there. Scroll. Oh, okay. That's it. Right here. Yes. Everything is recorded. Wake up, Neo. The Matrix has you. I have never played Rust, actually, which would make it an easy contest for you. All right. Okay, good. We got a little over about half an hour. Okay, so like in ancient times. I don't think that's how they worked with teachers, though. I don't think they just. Oh no, there's a game Rust too. Okay, well, either way, that's what you meant. All right. Oh yeah, we did talk about COD the other day. If you are off by 1 decimal point, does it mark it wrong? Yes. Yes, it does. Remember, rounding is very important. And it's important to be consistent and to follow directions. There's a procedure to how this works. Yeah. Well, and you were supposed to learn it the hard way over the weekend on the in-class assignment. So that was the idea. So, and I did work with several students yesterday who had issues with rounding. So, but again, this is how it's been. Like, we've been doing multiple choice stuff, and this is how I did the rounding. Can we go over the quiz? No, we're not going over the quiz. We're also not talking about ESO right now. We're talking about p-values. Okay. So, if you want me to go over the stuff I talked about last time, there's a video of it. Like, start there. Start by going back over the video, because I'm gonna say the same things mostly. So, watch the video, and then ask me a specific question. Because if I'm just gonna go over it, that means I'm just gonna go over the whole thing again. So, check your rounding. Round the square root, round the division, round the multiplication. It's there. Okay, we got to talk about this. There's recordings of things, please review those. I'm happy to work with you outside of class. We're not going to do it during class. Okay. I will be ignoring any other questions to this effect. Okay. P-values. Like I said, the p-value is measuring the support, or it's telling you, if a small p-value, it's telling you have a lack of support provided by the sample for the null hypothesis. So this is the percent chance that our respectable-looking man is innocent. So if he is very unlikely to be innocent, straight to jail. Oh, wrong button again. It helps to have the PowerPoint selected. Okay. Yep. You have to round all calculations. Okay. So, why did I spend so much time talking about how sure you want to be? Because this is the point of the significance level. How sure do you want to be? That's the significance level. I want to be 95% sure. Well, then the significance of alpha, 0.05, means that if the p-value is less than 5%, then there is a greater than 95% or greater chance that the man's guilty. And as sad as it is, he has to be punished. That's the rules of society. So, how much evidence do we have? Well, we send the man to jail if the p-value is less than or equal to alpha. Okay, so here are some guidelines more than actual rules. Okay, if the p-value is less than 0.01, that means there is a 99 point something % chance that the null hypothesis is wrong, that our respectable man is actually guilty. If we have between 0.01 and 0.05, that's associated with a 95 to 99% chance that the man is guilty, that the null hypothesis is wrong. Between 0.05 and 0.1 is between 90 and 95% chance. So you're seeing this scale, right? Very small chance that he's innocent. Pretty small chance that he's innocent. Mostly small chance that he's innocent. And then, so you can decide, if you're getting to make the decisions later in life, awesome. You can set your own confidence values. Sometimes people will use like 85% or 80%, and that's fine. Those are the cutoffs they'll use. But in our class, we'll use 90, 95, or 99%. We'll use one of those three. So generally, if what you have is less than 1%, you can call that overwhelming evidence, right? You're less than 1%. That's quite likely that the null hypothesis is wrong, that the man is guilty. It's hard to really do better than that. You're just at fractions of a percent at that point. It's hard to be like meaningfully different. Between 1% and 5%, okay, That's still pretty strong evidence. Like, most people would take most bets if you had a 95% chance of winning it. Right? You know, okay, double or nothing. 95% chance of winning. Yeah. I'll take it. Sure. Right? Will I take it 20 times in a row? No, but I'll take it a few times. Because 95% chance is pretty good. Even like 90% chance, that's still pretty good. You know, it's not as strong. And we might call it weak evidence. So it is evidence. Like, it is meaningful evidence that the guy's guilty. But it's not as strong as you might want it to be. And then less than 10%, you can say no. Now, you might decide that, hey, 95% is good enough for me. That's overwhelming in my book. Cool. 90 to 95, strong. 85 to 90, weak. Less than 85, insufficient. Whatever. You know, these are guidelines. This is a kind of a structure you might look at for problems. It's not that important that it's these exact numbers. I don't want you to memorize this table and be like, well, it doesn't say 0.05, so no. Don't. It's not. Again, this is my Pirates of the Caribbean impersonation. It's more of a guideline than an actual rule. All right? It's a guideline. It's a suggestion. It's more of a suggestion. That's from some other movie. No, I think more of a gesture. This is a comedian talking about the invention of the Heimlich maneuver. And he's like, well, it's not really a maneuver. It's more like a gesture at the moment. It's like a symbolism that you're trying to help the person. Okay. Okay, so let's say that there's a whole other part of this that we're going to skip, which is the cutoff value approach, I think they call it, or the I'm blanking on the name. I just looked at it. Critical value. There we go. Wrong C word. Critical value approach. So you can basically see both on the slide right here. So we know if I say, this is a one-tailed test, we're looking at a 10% chance that it's over here. Let me keep my hand on the screen. 10% chance that it's over here, 90% chance that it's over here. Okay? That's what we're worried about. We want it to be in this 10% region over here. Okay? So that's a 90% alpha of 0.1. 90% confidence level of 0.1. And let's say we calculate it, we find a z-score of negative 1.46, which corresponds to a p-value of 0.072, and that's less than alpha. 0.07 is less than 0.1, so we reject the null hypothesis. It's pretty much that straightforward. I tell you what the cutoff value is, right? It's alpha, 0.1. That's the cutoff. You compute the z or the t, and then you look up what that z or t value corresponds to. Oh, a probability of this number. Is it less than 0.1? Yes. Straight to jail. Otherwise, you can't convict. Maybe they are guilty, but you have an 87% chance, not a 90%. That's not good enough. It's innocent until proven guilty. And maybe you'll even sleep easier tonight because that man gets to go home to his daughter. So don't be in a hurry to convict your null hypothesis. So the critical value approach is just saying, well, if I know what the cutoff is, I know that an alpha of 0.1 is associated with a z-score of negative 1.28. I don't even need the p-value. I can just look at this, compare it to that, and see, is this farther away from zero than that? And if it is, reject. The trouble is, I don't normally give you the z-score. I normally give you the alpha. So you're either going to have to do two conversions either way. And absolutely. Yes. Yes, you do. Yeah. You're asking the question as I'm explaining it. Again, with the delay, that was excellent timing. I mean, spot on. Excellent timing. Exactly. It's no easier. It sounds easier, but it's actually, it's no easier and it's worse. Because the p-value is actually a lot more valuable than a yes or no answer, right? If I just say, is the p-value lower than the cutoff, yes or no, it doesn't tell me anything. Is it 0.99 or is it 0.011, 0.00001? Those are all yes, smaller than 0.1. But those are very, very different answers, right? One of those is overwhelming evidence, one of them is strong evidence, and one of them is barely even considered weak evidence by our guidelines before. So it's actually a lot better to just use the p-value, compare p-value to the cutoff of 0.1 in this case, or 0.05, whatever it is. Use the p-value and compare it to the thing. And in fact, a lot of statisticians will tell you, don't even have a confidence level. Just report the p-value and then maybe draw conclusions from that. Don't even talk about the null hypothesis rejecting. Just say, don't talk about the man going to jail, metaphorically. Just say, the p-value is 0.07. And so we this is evidence to support our claim. Just supports the null hypothesis or something like that. You can just report the p-value, and that tells the reader so much more. And if a reader doesn't know what the p-value is, then you probably don't want to talk too much about rejecting the null hypothesis because that's going to be unfamiliar as well. So just use the p-value. It's just better. We can do the same thing on the upper side. Compare your p-value to the alpha. Either way, you're going to have hopefully small values of p, which will compare to your alpha value. Same thing on the upper side. Okay. Critical value. Skips. Okay. There are 5 steps of hypothesis testing. Oh, my back's been hurting today. Sorry. Oh, that was really good. That was a good back stretch. Okay. Whew, I needed that. Got at least 5 vertebrae popped. Oh, yeah. That's what I like. I need a massage, guys. I don't know about you, but it'd be really nice. Oh, well. I'll just get a foam roller or something. It's the same thing, right? Anyway, hypothesis testing. Extra credit for one. If you drove 9 hours here, I'd feel really guilty, but no. That'd be very sweet, though. Or desperate and creepy. One of the two. Hard to say. It's amazing how often those 2 threats go inside. Man, that movie's so quotable. Okay. Step 1. Hypotheses. Which, truth be told, I genuinely believe that the hypotheses are the hardest part. Once you get more practiced with this, which it's hard to do in only a few days, but in time, this will be the part that's hardest to do. The null and alternative hypotheses are the most challenging. That's step 1. We talked about that last time. Step 2, specify the level of significance alpha. That's going to be given in the problem statement. Step 3, collect the sample data. Okay, well, I'm just going to give you the sample. And compute the value of the test statistic. So really, you can kind of pretend, for the sake of the class anyway, you can ignore this part right here and just say compute the value of the test statistic. That's step 3. Okay. And then obviously we're just doing the p-value part, so ignore that's there. Use the value of the t-statistic to compute the p-value. Step 5, reject based on the probability that the null hypothesis is in fact true. If the probability is quite low, below the alpha, then we reject. So develop hypotheses. State your level of significance. Compute the test statistic. Use the test statistic to compute the p-value, and then decide if you reject or fail to reject. So if you look at the practice exam, there are the same questions that I asked today on the quiz, same questions I asked on the in-class assignment. Those are still the same questions that are on the practice exam. And guess what? They're going to be the same questions on the real exam. So if you have questions, I'm not trying to tell you I'm not going to help you, but I don't want to reteach a lecture instead of teaching this one. So go watch the other video and then ask me questions. And I'll be more than happy to work with you. I promise. I really will. Just start there. Start there. Okay, so it's the same questions. What I was trying to get to, so the new information here is that the questions for Chapter 9 on the practice exam, I may have just put one question from Chapter 9. The Chapter 9 questions kind of have this format on the slide here. So there's like blank number 1, develop the null and alternative hypotheses. So there'll be like a blank or 2 about defining the hypotheses. The level of significance is coming straight from the problem statement. I guess I should maybe put a blank in there. That might be worth doing. Compute the value of the test statistic. So you'll be asked, like, what's the test statistic? That's a blank. Put that in there. What is the associated p-value? You look that up. You put that in there. And then reject or fail to reject. And by the way, you will be typing in the words reject or fail to reject. I've gotten frustrated with how the D2L systems work for questions. As far as I know, there is no way to do random blocks of questions, meaning I can't define 5 versions of 3 questions and then get one of the 5 groups of questions. I can do 5 different versions of each of the 3 questions, and it'll pick any random question, but it's not going to be coherent. So if I'm going to do 3-part questions, it has to all be the same format type. They all have to be short answers, so I can't do like a drop down or something, which is what I would have done, reject or fail to reject, like a drop down, but it won't let me. So that's annoying. But it's what it is. So, develop your hypotheses, specify significance, compute the test statistic, compute the p-value, reject or fail to reject. Okay, let's do an example. Just like I've done in the last chapter. So if you have questions about previous stuff, you want to see a breakdown of the questions, go look at the last chapter. Same thing. Go look at those examples. They're there. There are examples there. Maybe not of the rounding that we're doing for the class. Otherwise, just round everything if it's not a table value. It's actually simple. If you're not pulling a value from the table, round every step. Just round everything. Have you seen Star Wars? When Adam Driver's like, fire everything, except it's round everything and not nearly as dramatic. Round everything. And then you still can't kill whatever Carrie Fisher's character is called. Just blanking. It's fine. Leia? My brain's like, Lena, everything. Leia. It's Leia. Okay, I can do it. Woo, brain. It's in there. I can tell you Adam Driver and tell you their actors' names. I didn't say it was good. I have several issues with that scene, and I'll complain about it off stream. Not during class, I mean. I'm doing it on stream. I don't care. It's not offensive. It's just not relevant to class. Okay. Example. Response times for a random sample of 40 medical emergencies. Okay. I'm going to keep up with my tradition of sample of 40. Okay, that's good. Tabulated, put into a table. Okay. Sample mean. All right, that's good. Sample mean, 13.25. Population standard deviation. Okay, so for one thing, boom, population standard deviation. I know that this is a sigma known case. I know it says it at the top of the screen, but hey, it's still good to know. Sigma known. Therefore, I can use z-scores. Good. Population standard deviation is 3.2. Okay, so this is my sigma. Okay. I'm going to do an April Fool's stream. That'd be fun. We didn't have April Fool's in class. Oh, we did have April Fool's in class. Oh, well. Maybe someday. I don't know what I would do. I can't keep a straight face. I'm not very good at that, so I have a hard time. Okay, so let's keep going. EMS director wants to perform a hypothesis test with a 0.05 level of significance. Okay. Determining whether or not the service goal of 12 minutes or less while I yell at my dog. What are you... The best thing about dogs not speaking English is you can yell things like, "What are those?" at like Vine references, and he just knows that he's being yelled at. It's the best part of them not speaking English. Yes, that's what I just did. If you saw this hand gesture, that was me yelling, "What are those?" at my dog. He's on a different floor, so I have to yell because he's barking, and he's up like 2 floors. I don't know if you can hear that, but he's not a puppy. I can tell you that. He's 8, and he's a jerk. Like, I have to walk him on a leash because he runs at people. And he's big, so it was scary. He made a child cry in my neighborhood a couple weeks ago. He didn't like bite him or anything, but it's just like a big dog running at you. He's kind of a jerk, unfortunately. Like, he's really sweet, but he's overprotective. And so it's like, all right, you got to chill. Okay. Speaking of we got to chill, we got to fidget spin our way to church. And that's a really old meme. I'm sorry. Sigma known p-values. Okay. He's very distracting. Okay, step 1. Develop hypotheses. Let's go back. I underlined it. Okay, service goal, 12 minutes or less. Okay. H naught. Our claim, that's our innocent until proven guilty, is that we're meeting our goal of 12 minutes or less. Okay. And so less than or equal to, right, 12 minutes or less. So that's the equals. That's the 12 minutes or less, which leaves the greater than portion for the alternative. Remember, this sign and this sign will always point opposite directions, or it'll be equal, not equal to, and then there's always going to be an equivalent to in this part. It'll either be a comparative and equal, or it'll be equal to, and then this will either be not equal to, or it'll be specifically one direction. I know, Annie. Like, I feel so bad. I don't want to, like, you have to discipline, though, so I want to get him a bark collar. Because that's the only other thing, because he just ignores me. Like, I'll look at him and be like, "Stop barking." And he's like, "Bob." Like, he just ignores me. Okay. Compute the value of a test statistic. All right. So, here's our z value formula. X bar, our critical value, our value of interest. 13.25, if you want to see where that came from. That's underlined here. Sample mean, 13.25. I kind of went back right here. 13.25. All right, I'm going to do it this way. Okay, 13.25 minus the sample average of claimed average of 12. Divided by the standard deviation of the sampling distribution, which is defined as the population standard deviation divided by the square root of the sample size. Now, in the lecture slides, I don't remember exactly how they're rounding it, but again, for my assignments, because we all have to agree on something, there's no way for D2L to understand rounding. Another one of my issues. I can't do multi-blank arithmetic questions. So I have to manually type in every answer, and there's no way for me to know what way you might round unless you follow this schema that I've defined. So in this case, you would do square root of 40 rounded to 2 decimal places. And then you do 3.2 divided by whatever your rounded of this is. It's about 6.3, 6.3, something like that, I think. 6. No, it's more than that, 6.5 maybe. Anyway, whatever it is. So, and then you're going to round it. And so after you do that division, you round that. Subtraction doesn't require rounding. And then you do the division and round again. Those are the steps. In this case, z of 2.47 is your result. That's step 3. Step 4, compute the p-value. No, you cannot just plug in everything at once. That's what rounding all calculations is for. Round all the calculations. Okay. Which has been how it's been in the class. Like this is how it's been when we did multiple choice stuff. Like it's the same thing. You have to get the right answer. Now on multiple choice, it's easier because you're like, oh yeah, I'm pretty close. And so you can just kind of like hope you got it right. So we've kind of gotten away with it before. But that doesn't work in this case. You have to get it right. You have to follow the directions exactly. But this is how I've done the answer keys for like the whole semester. I don't know what that is. P-value for z of 2.47. Look it up on the z table. That gives us a cumulative probability, so left to right of, or I guess for you guys it's this way, right? Left to right of 0.9932. And you subtract that from 1, which gives us 0.0068. So there's no reason to round values from a table. They're already rounded for you. Just take the value from the table. If you do multiplication or division with it afterwards, you can round it. But like with this, there's no reason to round this. So just 0.0068. But I'll tell you in the problem if I want like 2 decimals or 4 decimals. But generally speaking, you should be rounding multiplication and division. There's no need to round subtraction. You might as well just keep it. Because you're going to be rounding small numbers, and that's bad. You don't want to do that. Okay, last step, determine whether to reject the null hypothesis. 0.0068 less than or equal to alpha of 0.05. Okay, this number is less than that one, so we reject. And therefore, we can say that there is significant evidence that Metro EMS is not meeting the response goal. So, that's the process. Make your hypotheses. Compute your test statistic. Look up the p-value. Compare it to the cutoff. That's what we're doing in this chapter. The only other thing you need to know is that this is for a one-tailed test. So there's an asterisk here. This is the way it works for a one-tailed test. There's one more thing you need to know. Oh, and here's the little picture, by the way. One more thing you need to know, and that is, what do you do if you have a two-tailed test? Well, basically, all that you do, there's two perspectives. Either you do what this says, which is double the tail area obtained in step 2. So, like, whatever your p-value is, you double it. Like, I got 0.03. Okay, well, it's actually 0.06. Pretend it were 0.06. If the p-value you get in well, we're calling it step 2 here. It was step 4 on the previous steps. Take your answer from step 4 and double it. So this is on a two-tailed test, which means like if you have the, where's the example problem? This is it. Where's the thing? Yes. Okay. If you have an equality, this is a two-tailed test. So if you don't have equal or not equal to, it's one-tailed. If you have like less than, equal to, and then greater than, something like that, that's one-tailed. So if you have this format, equal to in the null, not equal to in the alternative, then whenever you compute your p-value, double it. And the reason for that is essentially because we were willing to accept, or we were willing to reject the hypothesis based on values on either side. And so when you say 95% confidence, all of this is 95%. Which means that instead of having 5% on the side, you actually only have 2.5% on the side. So, like I told you, there's two perspectives. You can either double the p-value, or you can cut in half your cutoff value. So if it's a 95% confidence level, that's a 5% confidence, and so you can cut that in half to 0.025, compare your p-value to 0.025, which is kind of what this is doing here, alpha over 2, or you can double the p-value. So if you double the p-value, then you can compare a doubled p to the full alpha instead of a halved alpha. Compare a regular p to a halved alpha. Personally, I think doubling the p-value is easier, but either one's fine. So the one that's in the slides that we just talked, that I just showed you, there we go. Right here. Double the tail area obtained in step 2. Don't double the z value. Double the p value. Very important distinction. Double the p value. Okay. That's everything. There's more here in the slides. I wish we had time to go over it. Sadly, we don't, because we're out of time in our last lecture. Do you guys know who Donna Summer is? She had this incredibly famous song called Last Dance. And I might play it because this is it. Our last dance together. Yes, I will be on Discord. I am more than happy to work with you guys. But there's no reason for me to repeat myself before you watch the video. So, if you have a specific question, I don't understand this part, please let me know. I'll be on Discord. I'm more than happy to work with you. But take a look at the video. See if that helps. Not just you specifically, just like people in general. Not just you specifically. Just, because several people had questions. So, general blanket statement. Well, their fur is clear, right? They're white. Right? Is that true? Their fur is clear. That's a fascinating fact. I can't top that. I have no facts that are cooler than that information. Which means I'm ending the video here. With that, we've peaked. Go out while you're ahead, right? So it's what Kevin Spacey said in 21. Not that you should ever take Kevin Spacey's character's advice seriously, because they're always nut jobs, but, I'm not sure what that says about Kevin Spacey. Their skin's black? That would be advisable in a cold climate, right? Keeps you warmer. Wait, but how, if they're clear and their skin's black, that would make them look black. Confused. I will Google this later. Subscribe now for polar bear facts. Want to hear the Star Wars rant? All right. Well, cut the YouTube video. We're after class, so it's after hours. We can talk about whatever we want now. Folks, this is it. Last video. So, thanks for a great semester. See you on the flip side.